Today we're testing the supercapacitor ride-through ability of the bolt. The supercapacitor provides power to the bolt when AC voltage is lost. The bolt normally powers itself on channel 1 AC voltage, and during an interruption or recloser operations, that voltage can go away. And the supercapacitor provides several minutes of runtime for the bolt during that period. And it's important to be able to operate for several minutes to catch those recloser events. And we are going to test this with a simulated recloser sequence. We have a 3-phase power supply, and phase A, B, and C of the power supply is connected to the 3 input channels of the bolt. And we have an incandescent bulb on channel 1, so you can visibly see what we're doing with the voltage. In this scenario, we are simulating a recloser that will operate immediately for 8 cycles, trying to close during a fault. And during that fault, it's a single phase fault, so the voltage on phase A drops, but the voltage on the other 2 phases will increase. Voltage swells happen with a type 1 sags, where fault current flows on phase A and pulls the neutral away from the other 2 phases. So the bolt will record a deep voltage sag on channel 1 and also an interruption when the recloser opens, and a voltage swell on the other 2 phases. And those swells are important for power quality, and so you want to be able to record those cleanly during the sequence. This recloser sequence is set to reclose immediately, and then another reclose attempt at 5 seconds, and then 30 seconds. And finally, a long sequence. The last one is 3 minutes later, where the recloser will try to one last time to clear the fault. And then the fault clears in the simulation and power is restored. So we are going to give the bolt a test here to make sure it captures all those events cleanly. So I'll begin the test. And you can see when the recloser tries to close again, you'll see a very dim amount of light from the bulb during that deep voltage sag. And we can see from the LEDs, the bolt is still recording. And this bolt is actually still connected through Wi-Fi, and it will send alerts during this period to PQ Canvas, and we can check the PQ Canvas recording as soon as this is done to make sure that everything was recorded correctly. You can check the supercapacitor voltage on the bolt. I'm actually connected to the bolt through Wi-Fi during this time. We still have a good amount of charge, 3.7 volts on the supercapacitors at this point. And we've gone through the reclose operations that are very quick. The immediate one, the 5-second and 15-second. Now we're waiting for the 3-minute attempt. And now the recloser has made one final attempt to close, and this time it was able to clear the fault, and the circuit is back in normal operation. And the bolt has been running this entire time. The supercapacitor dropped down to 3.4 volts, so we still have a little bit of power left in the supercapacitor. And now we can check the data in PQ Canvas to make sure that it recorded each of those reclose attempts cleanly, and also recorded the swells on the other 2 phases. So to do that, I will jump onto PQ Canvas and take a look. Okay, I've logged into PQ Canvas, and we'll take a look at this bolt's recording. We'll look at the interval data. Zoom into this session, and we can see before the test, we were at 120, 120, and 120 on all 3 phases. And we can see the recloser sequence here, where during the test, phases B and C go up to about 135 volts, while phase A is down here at about 35 volts, while the fault current is flowing. And we can see the swells on the other 2 phases, and then interruptions where there is no voltage while the recloser is actually open. And then at the end, we can see that the voltage was restored in all 3 phases cleanly. But the supercapacitor ride-through is designed to be longer than any recloser sequence that a utility might have, so that the sequence of close opens can be captured cleanly, and we can capture not only the deep voltage sags on one phase, but the voltage swells on the other phases. And in addition, we can see that the bolt has generated a slew of emails. I have this bolt configured in PQ Canvas to generate emails for each waveform capture and for low and high voltage conditions. So we have several alarm conditions being generated during the sequence of events, and we are getting the notifications in real time as these are happening, since this bolt is also networked through Wi-Fi. And the supercapacitor has enough power to allow that to happen also, for those alerts to get through during the event itself. So the bolt has passed the supercapacitor ride-through test with flying colors.